Hello everyone, welcome back. This is the last lecture of the third week, and as I said in the previous lecture, we will take you to a beautiful place called Tetuldanga, where we will see in a single exposure all kinds of fold superposition. This is a spectacular outcrop and we will learn a lot of things. So without wasting much time, let's go to Tetuldanga. We are in a very special location today. So the place is Tetuldanga. It's a village, very small village in Ghatshila, and the place is about 5.4 kilometers away from Ghatshila station. There is a narrow road, one has to drive about 5.4 kilometers from the station, and then left side of the road is the village Tetuldanga. This exposure particularly took attention of structural geologists in particular for many years, and therefore I decided to include this particular exposure in this lecture separately. The beauty of this exposure is it displays superposed folding in a spectacular manner. The exposure is not that very much big, so in lengthwise it is about 48 meters. By the way, north is towards this side on my left, and as you can see probably from this view that the exposure from this side, it has a general trend of east west, and then it turns from here, goes to that side almost north south. So it makes a turn here, big turn here. It is thinner on this side and becomes thicker on that side. The rock is metapelitic. We have some thick quartz rich layers here and there, but it mostly contains quartz, mica, feldspar and some metamorphic minerals including staurolites. The overall deformation of this region is very straightforward. It has 3 generations of folds, and at the same time it records some penny-contemporaneous structures. The way we will show you this exposure or explain the different features is that we first show you the entire image, we make them in grids, so that you can have a reference where we are when I will explain different segments of this place. Most importantly, there are a lot of things that one can do or one can learn from this exposure. We will very specifically remain focused in explaining the superposed deformation, and in some places we will also look at the outcrop patterns of superposed deformation. We will also see how the different folds interfere with each other, and we will also see how different foliations also play with the previous or latter foliations, including the primary layering, that is S0. We will do some measurements here as well for you, and we will present the entire area as a structural map, so that you can understand in a better way that how to prepare a structural map. We will do plain paper mapping here. Of course, I am not going to explain the processes of plain paper mapping, because any geological mapping is extremely difficult to perform online or teach online. One has to come to the place, understand the area, feel it, touch it, and then measure it, and then finally display all these measurements on a map. Just to give you an overview again, there you see a very gentle fold, then you can see some larger folds, and you also see this bigger fold. So, that clearly tells you that several orders of folds that goes on this way here, but I tell you that is the latest fold or the last fold, because this particular orientation of fold that we see here, this direction is undeformed. So, that tells you that this area, that this is the latest deformation. But what are the earlier deformations? Let us examine different places of this large exposure. So, this is our first location in this Tetuldanga exposure, and we are at the tail part or the furthest eastern part of this exposure. What you see here in this surface, I will explain you what this surface is actually, but you certainly can see that this surface is folded, right. You can see the traces here as well, but here as well you see it is folded like that. You also see the same fold here going like this, and you also see the crenulations along the same direction. Let us take this observation as observation 1, and from observation 1 what we see, that from crenulations this little undulations, then these ones you also see it here, and then finally this bigger one. So, we see here at least 3 orders of folds. Let us keep this as observation number 1. We also see that this surface itself is folded in this manner, and the best place to look at it, if you follow here, you probably can figure out the shadows going like this, and fold axis here is like that, and if you follow carefully, the entire surface is folded this way as well. So, we saw from observation 1 that it is folded like this, and then from observation 2 we see that it is folded like that. Now, the question comes, which one is first, this one or this one, or there is a previous one. Now, throughout this exposure we will see that this trend, this fold axis remains constant, and the axial planar foliation of this particular fold also remains constant. And if we try to take the measurement here of this, we will see that the trend of this fold axis is 310, and so is the strike of the axial planar foliation of this particular fold. Now, as I said that we will measure this trend throughout, and we see that this trend remain constant. So, that helps us to conclude that our observation number 1 here in this exposure, that is this fold, is the last one, because it remained undeformed. So, the previous one must be this, but what is the form surface? We see that form surface is also characterized by a number of compositional bandings this way. So, therefore, it tells you that this is a foliation plane that retains the traces of S0, and if you look here, you can see the traces, the compositional bandings are going like that. So, this must be a foliation plane which is the form surface. So, on this form surface we have formed the last fold, this one, and the previous fold, which is this one, and previous fold you can also see, we have seen it there, we can also visualize it here. okay. And the fold axis is exposed, one can measure that. And at the same time on the surface we see the striping lineations, that means traces of S0 bedding planes on the foliation surface. So, that is essentially the F1, right, and we see the striping lineations are going like this, and also this fold is going like this, which was our observation 2, this one, this fold. So, third observation, that the striping lineations which has same trend with the F2 in this case, our second observation, they are parallel. So, this must be the first fold and this is the second fold. So, we now conclude that here again F1 and F2, these two are coaxial and parallel to each other. We also see that axial planar cleavage here is almost parallel to S1, because we see the axial planes here like that. So, S0 and S1 are at very low angle, and that is why you see some traces here. And finally, the entire packet after folding F1, it made F2, and then finally it made F3 of different orders. We also see F2 of different orders in one of the next exposures. If we recall again our first two observations, first observation that this is the last fold, and then we have observed the second one, second observation, that this is the second fold or before the last fold. So, in other ways we have figured out that this one is the F3 and this one is the F2. Now, again if we ask this question other than what we have just discussed, that why this one is F2 and this one is F3, not vice versa. There are two ways you can figure it out. One way is that the interaction between these two folds. So, clearly they are at an angle, okay, not perfectly at right angle, because it is this way, it is that way. So, this is obtuse angle, this is the acute angle. So, therefore, these interactions between this fold and this fold should produce dome basin type of outcrops, and we see it here. You can see that the fold axis of F3 is going like this, fold axis of F2 is going like that. As a result, here we are forming a little dome, here and here and here and here we are forming a little basin. 4 little basins, one dome, we form another dome here and so on. We clearly see that if we try to follow this axis, we see that this axis of F2 fold is little longer compared to the axis here in this particular dome, or in other words the dome is elliptical, shape of the dome is elliptical. So, the long axis of the ellipse is the first fold and short axis of the ellipse is the second fold for this. This has been demonstrated by experiments. Another way to look at it is that we can figure out that this fold is tighter, that means interlimb angle of this fold is smaller than the interlimb angle of this fold. So, one was open fold, another was tighter fold. Now, we can look at it this way, that so the hinge line of this particular tighter fold on this side and hinge line of this particular tighter fold on this side are falling along a same line across the other fold. If that did not happen, that means here you have the hinge, and right after you cross this particular hinge of the other fold, if you form a trough, then this was the second fold and this was the first fold, but this is not the case here. I explain you with a piece of paper. If the first fold, for example, if this fold for example was earlier fold and it was a tighter one, then you can see if you have to fold a tighter one, you always have to fold it this way, and therefore you see that hinge on this side is making the trough on the other side, while this is your first hinge line. So, in that case, if that happens, then this is the hinge of the first fold and this is the hinge and trough of the second fold, but this is not the case here. What we see here is something like that. That hinge this side of this fold is also the hinge of the same fold, and therefore it happens only if the earlier folds were tighter like this, as it is in this in our case, and then you gently deform it to form such a fold. In this kind of fold, it is difficult to make it tighter, and this has also been demonstrated experimentally. Here we see the interaction again between F2 and F3 and spectacular Dombeschin structure. What do you see here? This is the hinge of F3, this is again a hinge of F3, and this one is also again a hinge of F3. So, these are the large order folds that we see here, or at least in this exposure the largest order we see. We also see some little wrinkles here and here some crenulations. So, these are also F3 of different order. Now, if you observe carefully and try to follow the shadow of this area, you see that the hinge of F3 is not straight, or in other words, it is not cylindrical. The plunge here is gentle, and then suddenly here it becomes steeper. Plunge here is gentle, it becomes steeper, 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 again little gentle, again steeper. Here plunge is gentle and getting steeper. So, the F3 is folded this way, and we know that that was F2. So, F2 is like this, and we also see the F2 small folds of F2 in this form. We also see the striping lineations, and again that tells you that F2 and F1 are coaxial or parallel here, and F3 is making the cross. Superposition here is between F1, F2 and F3. So, F1 and F2 are coaxial, F3 is the cross fold. As you can understand that this is the dome. This is one associated basin, this one is another associated basin. This is a dome, and here this depression is another basin. What we have done here, we have measured all these fold axes of F1 and F2 and also F3, and we will also see how beautifully in map we can see the interaction between F1, F2 and F3 give rise this spectacular dome basin structure. I am sitting on a section which is perpendicular to F3 in Tetuldanga. The section, as you can see, it is almost subvertical, and this is a classic place to demonstrate multi-layer buckling or multi-layer folding, also harmonic folding, and also so many things. Let us examine one after another. What do we see here? These are the traces of S0, as you can see, going like that. You can see them here as well, and here as well, appearing like a striping lineation everywhere. This is folded with different tightness, S0 here, and the fold we see here, as I said, this is a section perpendicular to F3. So, these folds that we see, these are actually F3 folds, the fold axis of which is going like that. You can see the fold axis exposed here. You also see the thickness of the layers changed here greatly. They folded together and giving rise the axial planar foliation of F3, which is S3, these ones, and they appear as spaced cleavage. We also see that thicker layers formed lower orders of folding. Let us follow this one. You can count number of waves here, and you can come here as well. You see the number of foldings here are much more. Particularly if we look at this place, you can see this is the fold axis of F3. This is a thicker layer here, it hardly got folded, but in this particular part you see tiny folds. So, in this particular section we see harmonic folds, in this particular section we see the rheological contrast, how do they create different orders of folds or their thickness variations. We also see the development of S3 because of the folding of S0 in this particular section. In addition to this, if we remember that here F1 and F2 throughout this exposure are almost parallel to each other, except some places, and those places we will mark in the map. But you can see here, this is a little gentler section, not exactly perpendicular section to F3, but we see this particular layer is going like that. It is folded here and it is also folded here, and this gives a very nice hook shaped outcrop, that is the example or an evidence of coaxial folding or type 3 type of superposition. So, we again by looking at this particular exposure or this particular area, we clearly understand that F1 and F2 here are coaxial, and this is how S3 is moving. Thank you for your time. Lot of things happened in this lecture and in this entire week in particular. My suggestion to you would be you may review these lectures several times, draw sketches on your notebooks, and also consult the textbooks where you will see some classical images, because in the field they get weathered, or sometimes because of the camera angles you may not see the things properly, where we try to explain you or we try to bring all information to you, but it is essential that you consult your textbooks and also you practice by yourself. So, thank you very much. We finish week 3, and in the next week we will essentially focus on brittle deformation together with some quantitative analysis of strain. Thank you very much. Stay safe.